Imagine this. You are standing on the surface of the moon. Above you, the black sky stretches forever, dotted with stars. But there is silence. No air, no water, no trees. Just endless gray lunar dust. Now, pause for a moment. What if I told you that this lifeless dust could be the key to building cities on the moon? Yes, you heard it right. The very soil beneath your feet, known as lunar regolith, might one day provide oxygen to breathe, metal for construction, and even solar panels for power. This is not science fiction. This is Blue Alchemist, a project by Blue Origin, aiming to turn the moon into a place where humans can not just visit, but live permanently. Blue Alchemist aims to transform lunar regolith into solar arrays, metals, and oxygen. And here comes the suspense. Just a few weeks ago, Blue Alchemist passed a critical milestone. The project has successfully cleared the Critical Design Review, CDR, which means the design is strong enough to move forward toward real testing. By the year 2026, Blue Origin plans to test this system in a simulated lunar environment. But wait, why is this so important? Because carrying everything from Earth to the moon is insanely expensive. Every single kilogram of oxygen, water, or metal we send to the moon costs millions of dollars. But with Blue Alchemist, astronauts won't need to carry everything with them. Instead, they can make it directly on the moon itself. Each kilogram of oxygen made on the moon is one less kilogram we need to launch from Earth. This changes everything. It's like learning how to grow crops on a desert island instead of importing food from across the ocean. So, how does this futuristic factory actually work? That's where the magic and the mystery begins. Before we continue, make sure you subscribe, like the video, so you can stay up to date on all the latest mysterious space discoveries. So, let's open the doors of this lunar factory of the future. At the heart of Blue Alchemist lies a strange but brilliant technology called Molten Regolith Electrolysis. Now what is that? Imagine taking the dust and rock from the moon, the regolith, and heating it until it becomes a molten soup of minerals. Once it's molten, you pass a powerful electric current through it, and then something magical happens. The mixture splits into oxygen and metals. Molten regolith electrolysis turns lunar dust into oxygen and valuable metals. On one side, you get oxygen, not just for astronauts to breathe, but also pure enough to be used as rocket fuel. On the other side, you get metals like iron, aluminum, and silicon, perfect for building habitats, tools, and even electronics. And here's the fascinating twist. The same silicon pulled from regolith can be purified to make solar cells. That means the moon could produce its own power stations. Endless fields of solar arrays made from lunar soil itself. The moon could build its own solar panels from its soil. Think about how game-changing this is. Right now, every mission to the moon depends on fragile supply chains from Earth. But with this, the moon becomes self-sufficient. Astronauts could breathe lunar oxygen, live in lunar shelters, and power everything using lunar-made solar energy. And there's more suspense here, because Blue Alchemist isn't stopping at the moon. The same process could be used on Mars. Imagine explorers landing on the red planet, setting up a small reactor, and within months, creating oxygen, fuel, and construction materials from Martian soil. This is why experts say, Blue Alchemist is not just a project, it is the foundation of permanent human settlement in space. But here's the big question. If this technology is so powerful, how will Blue Origin actually prove it works outside of Earth? That takes us to their next bold step, a full-scale demonstration in a simulated lunar environment. Now, let's move the clock forward to the year 2026. Blue Origin plans to run its first autonomous demonstration of Blue Alchemist in a simulated lunar environment. That means no more just theories and computer models. This will be a real prototype working under moon-like conditions. 2026, the year Blue Alchemist will face its first true test. If this demo succeeds, it opens the door to a completely new kind of exploration. Missions will no longer be visits to the moon. Instead, they will start looking like settlements. Bases that can grow, expand, and survive using what the moon itself provides. And here comes the part that makes investors and governments pay attention: the cost factor. Right now, launching material from Earth is the single biggest barrier to space colonization. But according to Blue Origin's projections, lunar landings could become 60% cheaper if fuel and resources are made locally. Blue Alchemist could cut lunar landing costs by 60%. And that's not all. Systems that rely on batteries or fuel cells could become 70% lighter because they could refuel with oxygen made directly on the moon. Lighter payloads mean cheaper rockets, cheaper logistics, and more room for science equipment or life support systems. Just imagine, instead of carrying tons of oxygen tanks from Earth, astronauts simply refill their tanks on the lunar surface. Instead of packing solar panels, they manufacture solar arrays on site. It's a shift from importing everything to locally manufacturing everything. But let's not forget, every great promise carries a shadow of uncertainty. Will the process really scale? Can the equipment survive the brutal lunar environment, extreme cold, intense heat, and sharp dust particles that can chew through machinery? This is where the suspense builds. Because while the technology looks perfect on paper, the real battlefield will be the moon itself. The ultimate test of Blue Alchemist is not in labs on Earth, but in the dust of the moon. And if it works, it won't just change how we explore the moon. It will rewrite the future of Mars missions, asteroid mining, and even deep space travel. Behind every breakthrough is a place where it was born. For Blue Alchemist, that place is the Space Resources Center of Excellence, a massive research campus built by Blue Origin. This facility is no ordinary lab. It spans over 3 acres with 60,000 square feet of cutting-edge laboratory space. More than 65 experts from different fields work here: chemists, engineers, material scientists, robotics specialists, all united by a single mission: to unlock the resources of other worlds. The world's largest dedicated facility for space resource prospecting. It is here that lunar dust is mimicked, melted, shocked with electricity, and turned into the building blocks of a new world. Step by step, this team is designing the technology that may one day supply entire lunar colonies with oxygen, metals, glass, and solar power systems. But here comes a fascinating twist in the story. Blue Alchemist is not just about the moon, it also has applications on Earth. The same molten regolith electrolysis process can be adapted to produce zero-carbon solar cells right here, using common feedstocks like desert sand. No water, no toxic chemicals, no carbon emissions. Imagine manufacturing clean energy systems at scale, without harming the environment. Blue Alchemist promises zero-carbon solar cell production on Earth. And that's not all. This technology can extract critical minerals and semiconductors, like silicon, from low-cost, unconventional ores. That means new ways to power our technology-driven world without depending on scarce or geopolitically sensitive resources. So, while the vision is to fuel astronauts on the moon, the reality is that this technology could also transform industries right here on Earth. It's a rare example where pushing into space actually sends innovations back to benefit our planet. And to add weight to all this, Blue Alchemist isn't a solo adventure. It's backed by NASA's Tipping Point program, a special initiative to push forward game-changing space technologies. NASA's involvement signals that this is more than hype. It's a project with real potential to reshape space exploration. Supported by NASA's Tipping Point Award. But here's the question that lingers. Can Blue Origin actually deliver? Because history shows us that not every space dream survives contact with reality. Every great invention carries with it a shadow, the risks and challenges that could stop it in its tracks. Blue Alchemist may sound like the perfect key to unlock the moon, but space has a way of humbling even the boldest ideas. So, what are the hurdles? First, the lunar environment itself. The moon is not friendly to machines. It has no atmosphere, which means wild swings in temperature, boiling hot in the daytime, freezing cold at night. Lunar temperatures swing from positive 120 degrees Celsius to minus 170 degrees Celsius. Any factory placed there must survive this constant punishment. Second, there's the dust problem. Lunar regolith is razor-sharp, made of tiny glassy fragments. On Apollo missions, this dust clung to everything: spacesuits, machines, even astronauts' lungs. For Blue Alchemist to work, its machinery must handle tons of abrasive dust without breaking down. Third, the question of scale. Making a few grams of oxygen in a lab is one thing, but producing tons of oxygen and building materials, enough to support a base of astronauts, requires huge reactors, constant power, and perfect reliability. Can Blue Alchemist scale from lab tests to full lunar industry? And then there's the money. Even if the technology works, deploying it on the moon will cost billions. Rockets, landers, reactors, power systems. It all adds up. Will governments and companies invest long enough to see it through? Here lies the suspense. If Blue Alchemist fails, the dream of cheap and sustainable lunar exploration could be delayed by decades. The moon would remain a place we only visit briefly, always tied to expensive supply lines from Earth. But if it succeeds, the future changes overnight. The moon becomes not just a destination, but a launch pad to the entire solar system. Astronauts could live there permanently. Missions to Mars could refuel before making the long journey. Even deep space expeditions could one day be supplied by materials harvested on the moon and asteroids. Blue Alchemist could transform the moon into humanity's first true off-world outpost. And that is why this project carries both incredible promise and incredible uncertainty. Let's imagine a future where Blue Alchemist succeeds. The year is not 2026, not even 2036, but let's leap 100 years into the future. Humanity is no longer just Earth-bound. Instead, we have thriving colonies on the moon, powered by solar arrays made from lunar soil. The moon as humanity's first permanent home beyond Earth. Astronauts no longer carry fuel or oxygen from Earth. They simply walk to a nearby station where lunar oxygen tanks are filled, ready for their habitats and rockets. Massive fields of moon-made solar panels power underground bases, shielded from radiation inside lava tubes. Now, imagine the same principle applied to Mars. The dusty red soil, once a barren desert, is transformed by reactors that pull out oxygen and metals. A crew landing on Mars doesn't just survive, they build. Factories turn Martian regolith into shelters, fuel depots, and even greenhouses. The same process that works on the moon could unlock Mars. And it doesn't stop there. Asteroids, those wandering rocks in space, could one day be harvested the same way. Rich in metals, they could become floating supply stations, feeding starships on their journeys deeper into the solar system. Now here's the suspenseful twist. This vision is not just about survival, it's about freedom. With local resources, humanity is no longer chained to Earth's launch pads. Every world we reach could support us, at least partly, using its own soil and rock. Think about it. Every great age of exploration on Earth began when humans learned to live off the land. Crossing oceans was only possible when sailors could resupply at islands. Space is the next ocean, and Blue Alchemist could be the technology that gives us our first safe harbors. From the moon to Mars to asteroids, space becomes a connected network, not a distant dream. Of course, this future is still uncertain, but it creates a thrilling possibility. In just a few generations, the night sky we look at from Earth may no longer be empty. It may hold cities, stations, and lights built from the dust of other worlds. Up to now, we've imagined how Blue Alchemist could change the moon, Mars, and beyond. But here's the surprising part of the story. This technology could also transform life here on Earth. How? Let's start with solar power. Right now, making solar panels on Earth is not exactly clean. The process often uses toxic chemicals, large amounts of water, and creates carbon emissions. But Blue Alchemist's method is completely different. Blue Alchemist offers a zero-carbon way to produce solar cells. Instead of chemicals and waste, it simply melts material, like sand, using electricity, and separates it into oxygen and pure silicon. That silicon is then refined to the high purity needed for solar cells. And because the method doesn't use harmful chemicals, it's environmentally friendly. Now imagine entire factories creating clean solar panels at scale, without damaging our planet. That means cheaper, greener energy for millions of homes. But there's more. The same process can extract critical minerals and semiconductors from unconventional ores. In simple terms, materials like silicon, aluminum, and iron could be harvested from lower-cost sources that we usually ignore today. Blue Alchemist could supply critical minerals for our technology-driven world. Think about the electronics we use every day: phones, laptops, cars, even medical equipment. All of them need these minerals. Right now, supply chains are fragile and often tied to geopolitics. But if Blue Alchemist technology can scale on Earth, it could give us new sources of raw materials that are cheaper, cleaner, and more secure. And here's a powerful twist. This is one of those rare cases where technology developed for space exploration comes back to Earth and solves environmental and economic challenges here. It means progress for space is also progress for Earth. The moon dust that teaches us to live in space might also teach us to live more sustainably on Earth. So while astronauts may one day breathe oxygen made from lunar regolith, people on Earth might enjoy cheaper clean energy, stronger supply chains, and a greener planet, thanks to the very same invention. Now, let's step back for a moment. Because as exciting as this all sounds, there's a shadow of doubt. History is full of ambitious space projects that started with fire and ended in silence. One perfect example is Breakthrough Starshot. Back in 2016, it was announced as a $100 million program to build laser-powered spacecraft that could travel to another star within a human lifetime. The idea captured imaginations around the world. Famous scientists, billionaires, and astronauts supported it. For a while, it looked unstoppable, but then it just went quiet. No big announcements, no major milestones, and slowly, the project faded away. Breakthrough Starshot, a dream that quietly disappeared. Why bring this up? Because it shows us how fragile big ideas can be. Just because a concept is exciting doesn't mean it will survive the harsh realities of funding, engineering, and politics. And this is where the suspense deepens for Blue Alchemist. Will it be another shining dream that disappears into silence? Or will it actually prove itself, step by step, until astronauts are breathing lunar oxygen and building lunar cities? Think about it. Right now, we're standing at the Critical Design Review milestone. That's like standing at the base of a mountain, looking up. The path to the top is steep, dangerous, and uncertain. Blue Alchemist has passed its Critical Design Review, but the real climb has only just begun. If Blue Origin and NASA push hard, fund consistently, and solve the problems of scale, dust, and lunar survival, then the moon could transform into humanity's first permanent outpost beyond Earth. But if momentum slows or funding dries up, it could meet the same fate as Breakthrough Starshot, remembered not as a turning point, but as a missed opportunity. This uncertainty is what makes the story so gripping. We are living through the chapter where humanity is trying to decide, will the moon remain barren dust, or will it become the seed of our interplanetary future? Close your eyes for a moment. And picture this. It's the year 2100. Humanity has grown beyond its cradle. The moon is no longer a lonely gray desert. Instead, you see clusters of glowing lunar cities. Habitats carved into lava tubes, powered by solar panels made from lunar dust. Greenhouses stretch across the regolith, filled with plants grown under artificial light. Astronauts walk outside, their suits carrying tanks of oxygen made on the moon itself. The moon, from barren dust to humanity's second home. From orbit, cargo ships arrive and refuel at depots filled with lunar-made rocket propellant. These ships don't stop there. They continue outward, to Mars, to asteroids, even to the outer planets. Each new mission begins not on Earth, but on the moon. And on Mars, another miracle unfolds. Factories powered by the same technology pull oxygen and metals from red soil. Settlers live in domes, shielded from the harsh winds, building a new world not with shipments from Earth, but with the very soil beneath their feet. Blue Alchemist could be the first step to turning barren worlds into living ones. Even deep space explorers benefit. Refueling stations built from asteroid material become stepping stones across the solar system. Missions that once felt impossible now look routine. Now think about this. All of it began with something so simple, turning dust into oxygen and rock into power. The smallest act of chemistry sparking the greatest leap of civilization. And here's the emotional hook. When future generations look back, they might remember this moment, when humanity decided not just to visit space, but to stay. When we learned to stop carrying our survival on our backs and instead live off the land of other worlds. The story of Blue Alchemist is not just about machines, it's about whether humanity chooses to become a multi-planet species. That is the suspense we stand in today. We don't know yet if this story ends in failure or triumph. But one thing is certain, the journey has already begun. So here we are, standing at the edge of a new era. For thousands of years, humans have looked up at the moon with wonder. It has been our companion in myths, poetry, and science. But until now, it has always been out of reach, a place we could visit, but never call home. Today, projects like Blue Alchemist dare to change that. They ask a bold question. What if the moon itself could give us everything we need to survive? And the answer is staggering. Oxygen to breathe, fuel to launch rockets, metals to build shelters, solar cells to power entire colonies, all from the dust beneath our feet. This is not just technology, it's a philosophy, a belief that humanity does not have to be tied forever to Earth's supply lines, that every world we reach can provide for us, if only we learn how to use its resources. But remember, the suspense is real. Will Blue Alchemist succeed or fade into history like other ambitious projects? That depends on the next steps, the next tests, and the determination to carry this vision forward. And here's where you, the viewer, come in. Because the future of space exploration is not just decided by engineers and astronauts, it's shaped by public curiosity, support, and imagination. The more people dream of living on the moon, the closer that dream becomes. The question is no longer, can we go to the moon? The question is, can we stay? So the next time you look up at the night sky and see that glowing disk, remember this. Somewhere, deep in a laboratory on Earth, scientists are already turning dust into oxygen, rock into power, and dreams into reality. The moon is waiting, and the story of Blue Alchemist may just be the first chapter in the greatest adventure humanity has ever told. If you enjoyed this journey into the future of space exploration, don't forget to hit that subscribe button. It helps you stay connected as we uncover more mysteries of the universe. And if this video sparked your curiosity, please give it a like. It tells me you want more stories like this. I'd also love to hear from you. Do you think projects like Blue Alchemist will succeed, or will they remain just dreams? Share your thoughts in the comments below, and if you have questions about space, the moon, or future colonies, drop them too. I might feature your question in the next episode. So, subscribe, like, comment, and ask your questions. Let's keep exploring the cosmos together.